Hello students, we'll move on to the next derivation, that is shape function in natural coordinate system of a 2D CST element. So till now we have discussed about 1D elements in our previous lectures, that is 1D linear element, 1D cubic element and 1D quadratic element. 1D linear, quadratic and cubic elements, we have discussed all the three derivations. Now we will move on to two-dimensional elements. So in the two-dimensional elements we have CST element. What is a CST element? CST is constant strain triangular element. So it is a triangular element which is a two-dimensional one. So we'll derive this derivation in the natural coordinate system. Okay. So here first, so this is in the global coordinate system. See, this is in the x and the y, and we have the element here. So let us number it 1, 2 and 3 nodes, that is the triangular element. And since it is a two-dimensional element, at each node there will be 2 degrees of freedom. That is, one is, if you take the displacement, that one is displacement in the one direction, q1 is displacement in the x direction, and q2 is the displacement in the y direction at node 1. Similarly, at node 2, q3 is the displacement in the x direction, q4 is the displacement in the y direction. Similarly, at node 3, q5 is the displacement in the x direction, q6 is the displacement in the y direction. Now let me write the coordinates. Node 1 is defined by x1 and y1 coordinate, node 2 is defined by x2 and y2 coordinate, and node 3 is defined by x3 and y3 coordinate. Now, since we need to derive it in the natural coordinate system, so the element is in global coordinate system. So we have to convert that into, or write that in the natural coordinate system. So this is how you write the same element in the natural coordinate system. So as we have discussed already, in the natural coordinate system, the axis will be zeta and neta axis. Okay, you will not have x and y axis in the natural coordinate system. So in the natural coordinate system, the axis is zeta axis and neta axis. So if I write the element in this natural coordinate system, and one more rule in the natural coordinate system is the origin will be within the coordinate axis. The origin lies within the coordinate axis. So if I write an element here, so there's an element written here in this natural coordinate system. Let me start one with this one, n1, n2 and n3. So n3 will be with the origin, that is node number 3 will be the origin, that is 0, 0. And n1 is the node 1, which is the coordinate. So in the natural coordinate system, the coordinates always varies from -1 to +1. Okay. So here in the x direction it is 1, that is in the zeta direction it is 1. Okay. So coordinates is 1, and in the y direction, that is in the neta direction it is 0. Okay. So it is 1, 0. Similarly this one, in the zeta direction it is 0. In the neta direction it is 1. So it is 0, 1. And the origin will be 0, 0. So this is the parent element in natural coordinate system. Okay. So we'll move on to the derivation. The figure shows the CST element in Cartesian coordinate or the global coordinate x and y having 3 nodes, and at each node 2 degrees of freedom. I am speaking about the first figure, this one, in the global coordinate. Okay, 2 degrees of freedom, that is xy displacement. That is, let q1, q3, q5 be displacements in x direction, and q2, q4, q6 be displacements in y direction. That is what we have shown here. So next, that is about figure 1. Now figure 2 shows master parent element mapped from global coordinate to natural coordinate. So we have mapped an element from global coordinate into natural coordinate. Let n1, n2 and n3 be the shape functions at nodes 1, 2 and 3 respectively. So n1, n2 and n3 be the shape functions at node 1, 2 and 3 respectively. Okay. So derivation is very simple. Now shape function at node 1, shape function at n1. So we have the polynomial function n1 is equals to alpha 1 plus alpha 2 zeta plus alpha 3 neta. So this polynomial function we have already derived at the starting of this module. I have taught you how to write the polynomial function for each element, for different elements, either it might be a linear element or a 1D element or a 2D element or a 3D element based on the Pascal's triangle. So we have written this equation n1 is equals to alpha 1 plus alpha 2 zeta plus alpha 3 neta. So there I have used, instead of alpha, I have used the notation a1 plus a2 zeta plus a3 neta. I have used it there. Nothing to worry, each author uses different notations. It's left to you to use whichever notation you want. So here instead of a1 I have used n1 is equals to alpha 1 plus alpha 2 zeta plus alpha 3 neta. Okay. So at node 1. So where is node 1? Here. This is at node 1. At node 1, n1 is equals to 1. What is zeta here? Zeta is 1 and neta is 0. So at node 1, n1 is equals to 1, zeta is equals to 1 and neta is equals to 0. How n1 is equals to 1? So you have to remember the properties of the shape function. According to the properties of the shape function, at that particular node, the shape function is unity, and all the other nodes, it is 0. Its value is 0. So based on that, I have written n1 is equals to 1, and this coordinates zeta is equals to 1 and neta is equals to 0. So if I substitute this value, n1 is equals to 1 and zeta is equals to 1 and neta is equals to 0 in equation 1. In this equation, I'll get n1 is 1, alpha 1 plus zeta is 1, so it becomes alpha 2, neta is 0, so it becomes 0. So I'll get 1 is equals to alpha 1 plus alpha 2. Forget this part, I'll tell you. Next, coming to node 2. When this one you are writing shape function for n1. So at node 2, when you are writing shape function for n1, at node 2, n1 will be equals to 0. How is that? Again, properties of shape function. According to properties of shape function, when you are writing shape function for that particular node, only that one will be 1 and other nodes will be 0. So we have 3 nodes here. So when you are writing for n1, at n1 will be 1 at 1, and at the other 2 nodes it is 0. n2 will be 0, n3 will be 0. Similarly, when you are writing for second node n2 will be 1, n3 and n1 will be 0. Similarly, when you are writing for n3 will be 1, n1 will be 0 and n2 will be 0. Okay. So we are writing for the n1. So here at node 2, n1 will be 0, and at node 2 what are the coordinates? Zeta is equals to 0 and neta is equals to 1. So zeta is equals to 0 and neta is equals to 1. So substitute these values again back in equation 1. You will get 0, that is n1 is equals to 0 is equals to alpha 1 plus alpha 2, that is zeta is equals to 0, and you will get alpha 3. Okay. Next, similarly at node 3. At node 3, you are writing shape function for n1. So that's why at node 3, n1 will be equals to 0. Okay. Zeta, what is zeta and neta at node 3? It is 0 and 0. So at node 3, zeta is equals to 0 and neta is equals to 0. So if you substitute all these 3 values in equation 1, that is in this equation, you will get alpha 1 is equals to 0. You will get alpha 1 is equals to 0. Okay. Now substitute this alpha 1 back in this equation. If you substitute alpha 1 is equals to 0 in this equation, what you will get? Alpha 2 is equals to 1. If you substitute alpha 1 in this equation, what you will get? Alpha 3 is equals to 0. Am I clear? Now substitute all these values, alpha 2, alpha 3 and alpha 1 back in equation 1. So substitute alpha 1, alpha 2, alpha 3 back in this equation. You will get n1 is equals to zeta. Substituting alpha 1, alpha 2, alpha 3 in equation 1, you will get n1 is equals to zeta. Very simple derivation. Similarly for node 2. So second, shape function at node 2. So earlier we wrote shape function at node 1. Now shape function at node 2. So here n2 is equals to, you're writing for node 2. So n2 is equals to alpha 4 plus alpha 5 zeta plus alpha 6 neta. You should not get confused between alpha 1, alpha 2, alpha 3. That's why I've continued it to alpha 4, alpha 5 and alpha 6. That's all. If you want, you can use different notation. Nothing wrong in that. Okay. So when you're writing for node 2 at node 1, so you're writing for node 2. So n2 will be 1 and n3 and n1 will be 0 according to the properties of shape function. So at node 1, n2 will be 0. Okay. Then what are the coordinates at node 1? Zeta is equals to 1, neta is equals to 0. Substitute that in the equation 2, you will get 0 is equals to alpha 4 plus alpha 5. Next, coming on to at node 2, n2 will be 1 because you are writing for node 2. When you are writing shape function for node 2, n2 will be 1. So n2 is equals to 1. What are the coordinates at node 2? Zeta is equals to 0 and neta is equals to 1. Zeta is equals to 0 and neta is equals to 1. Okay. So substitute these values back in equation 1. You will get 1 is equals to alpha 4 plus alpha 6. Okay. So next substitute at node 3. At node 3, n2 is equals to 0, zeta is equals to 0 and neta is equals to 0. If you substitute all these three, you will get 0. Alpha 4 is equals to 0. Now substitute alpha 4 back in this equation, you will get alpha 5 is equals to 0. Substitute alpha 4 back in this equation, you will get alpha 6 is equals to 1. So substitute this alpha 5, alpha 6 and alpha 4, that is alpha 4, alpha 5, alpha 6 back in equation 2. You will get n2 is equals to neta. Is this clear? So we have got n1 is equals to zeta and n2 is equals to neta. Okay. So next, last one, third one, shape function at node 3. Shape function at node 3. n3 is equals to alpha 7 plus alpha 8 zeta plus alpha 9 neta. A similar equation, same polynomial equation, only I have changed this alpha values, that's all. So let me take that as equation 3. So when you're writing shape function for node 3 at node 1, n1 will be 0, n2 will be 0 and n3 will be 1. Okay, so that's what I have written here. n3 will be 0, that is when you're writing for this, n3 will be 0 when you're writing for node 3, and since it is when you're writing for node 3, n3 will be 1 only at node 3. Is this clear? So at node 1, n3 will be equals to 0 and write those coordinates. Zeta is equals to 1, neta is equals to 0 at that particular node. Substitute these values in equation 3. You will get 0 is equals to alpha 7 plus alpha 8. So alpha 8 is equals to 0 is equals to alpha 7 plus alpha 8. So next at node 2, n3 is equals to 0. What are the coordinates? Zeta is equals to 0 and neta is equals to 1. Substitute those, so you will get 0 is equals to alpha 7 plus alpha 9. Okay. Next at node 3. At node 3, since you are writing the shape function for node 3, according to the properties of shape function, at that particular node n3 will be equals to 1. And the coordinates at node 3 is 0 and 0. Zeta is 0, neta is 0. So substituting these three values in this equation, you will get 1 is equals to alpha 7. 1 is equals to alpha 7. Now substitute this alpha 7 back in this equation, you will get alpha 8 is equals to minus 1. You can shift this 1 alpha 7 to the other side, you will get minus 1. Substituting this alpha 7 here, you will get alpha 9 is equals to minus 1. Now substituting all these three back in equation 3, you will get n3 is equals to 1 minus zeta minus neta. Okay. So you have got all the three shape functions, that is n1 here, n2 here and n3 here. Okay, that's all as the derivation. Next you should have to write the variation of so once you finish this derivation, next you have to write variation of shape function. So in the variation of shape function, write the same element, that is for node 1 1, 2 and 3. Okay, write the same element like this, like this. Okay, and once you write the element, when you are writing for node 1, at node 1 it is 1. From the properties of the shape function, we know that at n1 it will be 1, and at the other nodes it will be 0. This is to the other nodes, you have to drop the curve to the line to the 0, and thus shade this part from where you have dropped to 0, shade that part. Is this clear? Is this clear? You can see here. And similarly, when you are writing for node 2, write the same element. Write the same element like this. Okay, this is node 1, this is node 2, and this is node 3. This is for n2, that is node 2. When you're writing for n2, n2 is 1. So this is n2 will be 1, and at the other nodes it is 0. From here drop to third node it is 0. From here drop to this it is 0. And thus shade this part. Is this clear? Similarly, when you're writing for node 3, this is 1, this is 2, and this is 3. When you're writing for node 3, n3 is 1. This is n3. n3 will be equals to 1. And to the other nodes it is 0. Drop down to other nodes and then shade this part. Is this clear? So that's how it is written here in your notes. So when you're writing for n1, n1 is 1, and at the other nodes it is 0. When you're writing for n2, n2 is 1, and at the other nodes it is 0. When you're writing for n3, n3 is 1, and at the other nodes it is 0. Okay, I think this would be clear.